Have you ever been so hungry and starving, and then all of a sudden, cows fall from the sky? Well, if so, the rate at which cows are falling from the sky is a calculus problem that we will be going over today. But before we dive into that problem, let's talk about the AP Calculus exam. Every year, the AP Calc exam has an FRQ that deals with the rate at which something is happening. These problems are quite easy if you get the hang of them. So today, I'll show you some common pitfalls and give you some tips to avoid these mistakes. So here's a general statement that they might give you. They might give you a function that represents the rate at which something is happening. In this case, it's the rate at which cows are falling from the sky. Now, let's go over some tips that'll help you succeed in these problems. The first tip I have is to always consider the units of the problem. It could either be fish per second, apples per second, eggs per minute, TNT per hour, ender pearls per light year, cookies per nanosecond. The point is, pay attention to the units, because almost all FRQs give at least 1 point for writing the units. Here are some examples where units were important. On the 2013 AP Calculus exam, question 1 was dealing with the rate at which unprocessed gravel arrived at a processing plant. Part A asked students to find the derivative of the function at 5 hours, and used the correct units with interpretation. In this case, the units were tons per hour squared. When viewing the scoring guidelines, 1 point is awarded for the correct units and interpretations. Each FRQ is worth 9 points. If 1 point is rewarded just for correct units, this means roughly about 11% of your FRQ is rewarded just by acknowledging what units the problem is in. Going back to our original problem with the cows, knowing that units are so important now, something we would like to note is that the function given to us is in cows per second. The point is, pay attention to the units. The next step I have is on solving accumulation problems. A general question that AP exam might ask is how many things have accumulated at a certain time. In our case, it would be how many cows have fallen from the sky. Now let's say you wanted to see how many cows have fallen in the first 5 seconds. I mean, you could count how many cows have fallen, if you wanted to. But since we are given the rate at which cows are falling, we could use an integral. By taking the integral from our starting time to our ending time, we are able to find the amount of cows that have fell from the sky. Let's say we wanted to see how many cows have fallen in the first 5 seconds. Well, we'd have to take our integral from 0 seconds to 5 seconds of the function that we were given, and that would give us the amount of cows that have fallen in the first 5 seconds. So rounding to the nearest whole number, we can see that about 9 cows have fallen in the first 5 seconds. Now, there are 2 ways that AP exam likes to ask these type of questions. Let's see if you can spot the difference. The first question is asking how many cows fell to the ground in the first 5 seconds, whereas the second question is asking how many cows are on the ground at 5 seconds. The difference is that the second question makes you consider whether or not there were cows on the ground to begin with. For the sake of the second question, let's say there were 50 cows on the ground to begin with. This would change your answer by a lot, since now we would have to consider the initial condition that the problem has given us. So now not only do we have to consider the amount of cows that have fallen, we also have to consider the amount of cows that are already on the ground. We would do this by adding our initial condition to the integral of our rate of cows that are falling on the ground. So now it would be 50 plus our integral from 0 seconds to 5 seconds of our rate. So now going back to the 2 types of questions, for the first question, the answer would be 9 cows. However, for the second question, the answer would be 59 cows. This might seem like a simple thing to do. However, many students miss this point for not adding the initial condition. On the 2016 AP Calculus exam, students were given the rate at which water was entering a tank, along with the rate at which water was exiting the tank. They were also given an initial condition. A question that they were asked was to find the amount of water left in the tank after 8 hours. To solve this problem, students would have to take the integral of the rate of water in, subtracted by the rate of water out. This would give the accumulation of water after 8 hours. Then students would have to add the initial amount of water that was already in the tank from the start. However, when viewing student performance, many students missed the initial condition that was given in the problem. The point is, always pay attention to the initial condition in these types of accumulation problems. The last step I have is on whether a quantity is increasing or decreasing. A question that AP exam likes to ask is if a quantity is increasing or decreasing. Here are some examples. Going back to the 2013 AP Calculus exam, students were given the rate at which gravel arrived at a processing plant. They were then asked, is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5 hours? Show the work that leads to your answer. Another example is on the 2015 AP Calculus exam, students were given the rate at which rainwater flowed into a drain pipe. They were then asked, is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? Give a reason for your answer. This problem shows up time and time again, so let's apply this to our cal situation. Here's a question the AP exam would most likely ask. Is the amount of cows falling from the sky increasing or decreasing at t equals 4 seconds? Show the work that leads to your answer. So to solve this problem, we would have to look at the rate at which cows are falling and evaluate it at t equals 4. So when plugging in 4, we can see that our rate at which cows are falling at t equals 4 is positive. This means that the amount of cows falling is increasing at time t equals 4. Now this problem is very straightforward. However, there's a very identical problem that throws a lot of students off. Before I show you what the other problem is, I want to see if you can spot it first. Now I'm going to present two different scenarios, and I want to see if you can spot the difference between the two questions. Going back to the 2015 AP Calculus exam, water is flowing down a drain pipe at a rate r of t, and water is being drained at a rate of d of t. The question now, is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? Give a reason for your answer. Now let's go to a different scenario. On the 2019 AP Calculus exam, fish are entering a lake at a rate e of t and exiting at a rate l of t. The question now, is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m. t equals 5? Explain your reasoning. Here are the two questions side by side. Have you spotted the difference yet? The difference is that the scenario involving the water flowing down a drain pipe is asking about the rate of change of the quantity of water, whereas the scenario involving the fish is asking about the rate of the quantity of fish. This means that in the scenario of the water flowing down the drain pipe, we would just evaluate the rate of the amount of water at t equals 3, just like we did in the cal problem to determine whether the amount of water is increasing or decreasing. However, in the scenario of the fish entering and exiting the lake, we would have to take the derivative since now we are determining if the rate of fish is increasing or decreasing. To explain this more in a formal calculus sense, I've made a chart. In the drain pipe scenario, we were given the rate of water in and out. Then we were asked if the amount of water was increasing or decreasing, which could be found out by using the first derivative. We did that by plugging the number into the first derivative to see if the amount of water in the drain pipe was increasing or decreasing. However, in the fish scenario, we were given the rate of fish in and out, and we wanted to see if that was increasing or decreasing. So then we had to take the second derivative to analyze if the first derivative was increasing or decreasing. So then we had to plug in the number into the second derivative to see whether it was positive or negative, and that would tell us if the first derivative was increasing or decreasing. So the point of this tip is to be careful on what derivative you're using, because you want to make sure that you're answering exactly what the AP exam is looking for.